Hi guys, in this video what we're going to do is we're going to look at something called the product rule with differentiation. I'm going to go through a couple of examples and show you how it works. Okay, so the first thing is the product rule is given by dy dx is equal to u dv dx plus v du dx, and we use it when we have a product. So for example, you see example 1 here, we have x squared times sine x. Remember, a product is when we multiply two things together, and we've got two functions of x being multiplied together here, the x squared and the sine x. So how do we do it? Well, the first thing we do, I'm just going to rewrite this, y is equal to x squared sine x, is we get the two functions and we circle them. So here I've got x squared, and that's being multiplied by sine x. And I label one u, and I label the other v. I then go to the side, and I say, okay, u is equal to x squared. And what I'm going to do is I'm going to differentiate that u here with respect to the x on the other side. Okay, so if I do that, I'm going to get, instead of dy dx, I'm going to get du dx. And x squared, bring down the power, rewrite the x, take one off the power, we get 2x. I'm going to do exactly the same with the v. So v is equal to sine x. And if we look in our tables book, then we'll see that f dash x, or the derivative of sine x here, is equal to cos x. So let's write that down. So now what we have is dv dx is equal to cos x. Okay, now the product rule is given by this, where dy dx is equal to u by dv dx plus v times du dx. So the next thing we do is write it down. So we've got dy dx is equal to u by dv dx plus v by du dx. Please write it down before you start substituting things in, so you won't make a mistake. And we go across and we're just going to fill everything in. So that's equal to, our u is x squared, so x squared, by dv dx, well, dv dx is here, so that's cos x, so cos x, use brackets if you want, plus v, v is sine x, so let's put that down next, so plus sine x, and the last thing is du dx, which is 2x, so that's multiplied by 2x, I'm going to put that in a bracket there. I'm going to tidy it up, we're going to get x squared cos x plus, and I'm just going to change those around to get 2x sine x there, and I am now done. So let's have a look at another couple of examples. So here you can see this is a product. I have this bracket multiplied by this bracket. Now what I could do is I could actually multiply the brackets out, and I could solve this as I did on my previous video, but we're going to use the product rule to do this. So the first thing I need to do is to label them u. So this one's going to be my u, and the other one's going to be my v. Okay. Remember, dy dx, I'll write it down now, is equal to u dv dx plus v du dx. We go to the side. U is equal to x squared plus 2. I'm going to differentiate that now, and I'm going to get du dx is equal to, well, x squared, bring down the power, so that's 2, rewrite the x, take one off the power, so that's 2x to the 1, which is just 2x, and then the plus 2, it's a constant, and remember, if we differentiate a constant, then it disappears. Okay, next thing to do is v, so v is equal to 3x squared minus 1, so we're going to work out dv dx. So again, 3x squared, bring down the power, so 2 times 3 is 6, x to the 1, so that's equal to 6x. And again, we have another constant, a negative 1, so that's going to disappear. Fill in what we know, so we now know that dy dx is equal to u, which is x squared plus 2. Put it in a bracket. And what we have is, so that's u there, by dv dx, which is 6x. I can stick it behind the bracket here, or I can stick it in front. I'm going to put it in front, so I don't have to do it later. So 6x, x squared plus 2. And then what I have is plus, the next one is v. V is 3x squared minus 1, so 3x squared minus 1. Put in a bracket. And it's going to be du dx, which is 2x. Again, I'm just going to stick it in front. And now I can simplify this, I could multiply it out and simplify it, so let's do that. So I'm going to get, in this one, we've got 6x cubed plus 12x plus 6x cubed minus 2x. Collect the x cubes together, we get 12x cubed, and then what we have then is plus 10x, and that there is my dy dx of this particular function. Right, let's have a look at the last one here. We've got 3x minus 1 cos x. So again, you can see this is 3x minus 1 multiplied by cos x. So that means it is a product rule, exactly the same as what we've done before. U, v, go to the side, u is equal to 3x minus 1, du dx is equal to, it's just a number in front of the x here, so if that's the case we just drop the x to get 3, and the constant on the side there, the minus 1, that's going to disappear. We then have v is equal to cos x dv dx. We have a look at our table. Up here cos x goes to minus sine x, so equals minus sine x there. Okay, the rule is that dy dx is equal to u dv dx plus v du dx. Let's start sticking in these values. So u, which is 3x minus 1, so 3x minus 1, by dv dx, which is here, so that's minus sine x, plus, and we have v, which is cos x, multiplied by du dx, which is 3. Okay, so 3. We're then going to tidy it up, so I'm going to have minus 3x minus 1 sine x plus 3 cos x, and I'd probably multiply out the minus there to get minus 3x plus 1 sine x plus 3 cos x. I then probably change these around to get 1 minus 3x just so it's nicer. So I'll do that now to get 1 minus 3x sine x plus 3 cos x. And now I'm done.